Example 4. Find the roots of 6x squared minus x minus 2 equals 0. Step 1. A equals 6, b equals -1, c equals -2. Step 2. We need p plus q equals -1 and p times q equals 6 times -2 equals -12. The numbers are -4 and +3, -4 plus 3 equals -1, and -4 times 3 equals -12. Correct. Step 3. Split and group. 6x squared minus 4x plus 3x minus 2 equals 0. 2x times 3x minus 2, plus 1 times 3x minus 2 equals 0. So 3x minus 2 times 2x plus 1 equals 0. Step 4. Equate each factor to 0. 3x minus 2 equals 0 gives x equals 2 over 3. 2x plus 1 equals 0 gives x equals -1 over 2. The roots are x equals 2/3 and x equals -1/2. Example 5. Find the roots of 3x squared minus 2 root 6 times x plus 2 equals 0. Here a equals 3, b equals -2 root 6, c equals 2. We need p plus q equals -2 root 6 and p times q equals 3 times 2 equals 6. The numbers are -√6 and -√6, since their sum is -2 root 6 and their product is 6. Both equal -√6. Splitting, 3x squared minus root 6 times x minus root 6 times x plus 2 equals 0. Grouping, root 3 times x times root 3 times x minus root 2, minus root 2 times root 3 times x minus root 2 equals 0. So root 3 times x minus root 2, squared equals 0. This gives a repeated root x equals root 2 over root 3, which simplifies to root 6 over 3. Both roots are equal. This happens when the discriminant equals 0. Example 6. Find the dimensions of the prayer hall from the introduction. Recall the equation we built, 2x squared plus x minus 300 equals 0, where x is the breadth in meters. Step 1. A equals 2, b equals 1, c equals -300. Step 2. We need p plus q equals 1 and p times q equals 2 times -300 equals -600. The numbers are 25 and -24, 25 plus -24 equals 1, and 25 times -24 equals -600. Step 3. Split, 2x squared plus 25x minus 24x minus 300 equals 0. Group x times 2x plus 25, minus 12 times 2x plus 25 equals 0. So 2x plus 25 times x minus 12 equals 0. Step 4. 2x plus 25 equals 0 gives x equals -12.5, rejected, negative breadth. X minus 12 equals 0 gives x equals 12. Therefore the breadth is 12 meters, and the length is 2 times 12 plus 1 equals 25 meters. The prayer hall is 25 meters by 12 meters, with area 300 square meters. Verified. Example 7. Find the discriminant of 2x squared minus 4x plus 3 equals 0, and determine the nature of its roots. Step 1. Identify a equals 2, b equals -4, c equals 3. Step 2. Calculate d equals b squared minus 4ac. d equals -4 squared minus 4 times 2 times 3. d equals 16 minus 24 equals -8. Step 3. Since d is less than 0, the discriminant is negative. Therefore this equation has no real roots. The quadratic formula would require the square root of a negative number, which is not a real number. So there are no real solutions. Geometrically, the parabola y equals 2x squared minus 4x plus 3 lies entirely above the x-axis, never crossing it, confirming no real roots exist. Example 8. A pole stands at the boundary of a circular park whose diameter is 13 meters. The distances from the pole to two gates, A and B, on a diameter differ by 7 meters. Is it possible? If yes, find the distances. Step 1. Let the distance from the pole to gate A be x meters. Then the distance to gate B is x plus 7 meters, since they differ by 7. Step 2. Since the diameter AB subtends a right angle at any point on the circle, angle at the pole is 90 degrees. By Pythagoras, x squared plus 7 squared equals 13 squared. Step 3. Expanding x squared plus 14x plus 49 equals 169. So 2x squared plus 14x minus 120 equals 0. Dividing by 2x squared plus 7x minus 60 equals 0. Step 4. Discriminant d equals 49 plus 240 equals 289. Since d is positive, real roots exist. Root x equals negative 7 plus 17 over 2 equals 5 meters. The other root negative 12 is rejected since distance must be positive. Distance to gate A is 5 meters, distance to gate B is 12 meters. Yes, it is possible. Example 9. Find the discriminant of 3x squared minus 2x plus 1/3 equals 0, and determine the nature of its roots. Find them if real roots exist. Step 1. Identify A equals 3, B equals negative 2, C equals 1/3. Step 2. D equals B squared minus 4AC equals negative 2 squared minus 4 times 3 times 1/3. D equals 4 minus 4 equals 0. Step 3. Since D equals 0, the equation has two equal real roots. The repeated root is x equals negative b over 2a equals 2 over 6 equals 1/3. So both roots equal 1/3. Verification. 3 times 1/3 squared minus 2 times 1/3 plus 1/3 equals 3 times 1/9 minus 2/3 plus 1/3 equals 1/3 minus 2/3 plus 1/3 equals 0. Confirmed. When the discriminant is exactly 0, we always get a perfect square on the left side, and both roots are identical. Exercise 4.1, Question 1. Check whether each expression is a quadratic equation. Part 1 x plus 1 squared equals 2 times x minus 3. Expanding the left side x squared plus 2x plus 1 equals 2x minus 6. Rearranging x squared plus 7 equals 0. Yes, quadratic with A equals 1, B equals 0, C equals 7. Part 2x squared minus 2x equals negative 2 times 3 minus x. Right side, negative 6 plus 2x. So x squared minus 4x plus 6 equals 0. Yes, quadratic. Part 3x minus 2 times x plus 1 equals x minus 1 times x plus 3. Expanding both sides x squared minus x minus 2 equals x squared plus 2x minus 3. The x squared terms cancel, leaving negative 3x plus 1 equals 0. No, only degree 1. Part 4x minus 3 times 2x plus 1 equals x times x plus 5. Left, 2x squared minus 5x minus 3. Right x squared plus 5x. Rearranging x squared minus 10x minus 3 equals 0. Yes, quadratic. Part 5. 2x minus 1 times x minus 3 equals x plus 5 times x minus 1. This reduces to x squared minus 11x plus 8 equals 0. Yes, quadratic. Part 6x squared plus 3x plus 1 equals x minus 2 squared. The x squared cancels, leaving 7x minus 3 equals 0. No, only degree 1. Part 7x plus 2 cubed equals 2x times x squared minus 1. This produces a cubic term giving degree 3. No, not quadratic. Part 8x cubed minus 4x squared minus x plus 1 equals x minus 2 cubed. After expansion the cubes cancel and we get 2x squared minus 13x plus 9 equals 0. Yes, quadratic.